Hello everyone, welcome to Sources classes. This is Tushar Shaw, and in this video we will be continuing the JAM 2019 questions that we were solving since the last 5 or 6 videos, I guess 5 videos. Okay, so in the last video we did up till question number 25, so let us start from question number 26. Okay, so in this question it is given that in the following reaction of D-glucose the product P is formed. Okay, so let us draw the structure of glucose first. We have CH2OH over here. So H H OH H, and here it is OH H OH OH. Okay. Firstly, we give Br2 H2O. Okay. So what happens is this CHO group is oxidized to COH group, forming this is D-glucose. Okay. So the product from the will be D-gluconic acid. Okay. D-gluconic acid. So H H OH H and OH H OH OH. Okay. So this is the structure that would be formed. Yeah. And D-gluconic acid is the name. Gluconic acid. Now the second reagent that we give is H2O2 and Fe2SO4 whole 3. Okay. So what would happen is this CO2 would be released. Okay, so minus CO2 would be released. That this group would be like taken away, and the product that would be formed is this oxygen. This carbon would be oxidized to CHO. Okay, so CHO is there, CH2OH is here, and three chiral carbons will be there. Among the three, we have H, OH, and here H, OH, OH. Okay. So for the next three carbons, the configuration is the same. Okay. So this structure is called arabinose, D-arabinose. Okay. Now, the question asked the question this is the product P. Okay, this is the product P. Now the what is the product is it is not asked. The among the question is that is among the following compound which one will be giving the same product P under the identical reaction conditions. Okay, so in the in the options there is you have to just check whether the configuration of the last three carbons is the same for which compound. Okay, so in the option B I have checked all of them, so you can look at option B. It is the configuration is that is CH2OH, so H H OH OH, and here it is H H OH OH. Okay, so in these three carbons the configuration is same for that of glucose. Okay, so if this undergoes that reaction with firstly with Br2H2 and then with H2O2, the same dearabinose P would be formed. Okay, so obviously option B would be the correct option. Okay, you can check that in the other reactions what happens other compounds, the configuration of these three carbons is not the same, and therefore though the reaction would be taking place, this D-arabinose, that is the product P, would not be formed. Okay, so let us move on to the next question now. So this is question number 27. Okay, so question number 27 is kind of a tricky one. Okay, on the exam day, if you are like a master in, or like a super pro in organic chemistry, then you will be able to do this, because the first thing that is the molecule is very big, and the second thing, if you don't know how the reagent works, then doing this question is like impossible for you. Okay, and this is a very peculiar reagent that is given. So firstly we have to learn about the reagent. Okay, so we have given trifluoroacetic acid, TFAA, and H2O2. Okay, so what does firstly we have to look that trifluoroacetic anhydride, that is CF3, C double bond O, C double bond O, CF3. This reacts with H2O2 to give uh, uh, trifluoroacetic acid. Okay, for trifluoroacetic acid. So the structure would be C double bond O O H. Okay, and the remaining and the byproduct would be something that is not a concern, because the main reaction would be taking place via this compound. Okay, so let us take our reagent that we have. We have this. We have H over here. we have a ring over here, double bond O is there, a methyl group is there, and one OH is there. Okay, now we give F3, sorry, now what would happen is this H is there, O, C double bond O, CF3, this oxygen would take up this H. Okay, so let me just write down the reaction and then I'll explain. Okay, so okay, so then this minus charge would attack over here, this bond would open up. Okay, the compound that will be formed is uh, OH would be there, and here O, C double bond O, CF3 would be there. Okay, now what would happen is uh, so this lone pair of electrons would fall over here, and this bond would shift to this oxygen. Okay, so what would be forming is uh, I'm sorry. So this bond is obviously breaking. Okay, so we have where's the pointer? Yeah, so we have a methyl group over here. This side is attached. Okay, so we have the number of carbons is 1, 2, 3, 4. Okay, 4, and in the fifth, yeah, so 4 carbons is there. So 1, 2, 3, 4. So let me draw it a bit different. 1, 2, 3, 4, and here you have this COH group which is formed. Okay, and this obviously when this molecule leaves, okay, this bond is formed over here, and this molecule leaves as CF3 CO2 H. Okay, from where this H comes, this H is like attached then to this one. Okay, now the reaction is not finished yet, obviously. uh, Here is a carbocation formed because this bond has broken up, and here is one OH group. Okay, so this lone pair of OH would attack over here, and this H would be removed. Okay, H would be removed. So uh, this above the plane O would be there. Okay, then Me would shift down to below the plane. Okay, here would be one H over here. Here is also one H. Now, yeah, and this is the hydrogen, the methyl groups are there, and so this is the compound that is formed. Okay, in the options you can see that option A is the product that is formed over here. So that this is the product. So option A is the correct option. Okay. Okay, so yeah. Okay, so moving on to the next question, we have question number 28. Okay, so question number 28 says it says that the molecule is there, the chloropyridine derivative. Okay, and we give NaNH2 liquid and ammonia, liquid ammonia. Okay, so obviously a benzene mechanism would be taking place. So benzene, either this hydrogen would be taken up or this hydrogen would be taken up. Okay, forming now whether obviously you can see that with the pointer, yeah, so this hydrogen can be taken up, this hydrogen can be taken up, but in this case you can see that this hydrogen also has lone pairs, and this minus charge also would be having like a pair of electron, and therefore there would be a good steric repulsion between the the electron pairs. Okay, so what would be happening is this H would not be taken up, instead this H would be taken up as the major product. Okay, So NH2 would be taking up this pair and leaving as NH3. They are making a minus charge over here. Now this not minus charge, obviously this bond will fall over here, and this Cl would be released as Cl minus, forming a benzene. Okay. Now this obviously this is not benzene, so the benzene cannot be formed. But you can say this had pyridine. Okay, but that is not any compound. Okay, so we just write this as benzene intermediate. Okay. Now if we then NH2 group would be attacking either from here or from the this carbon. Okay, forming two specific compounds. Okay. Firstly this NH2, and then this NH2. Okay. So these two are the products. In the option you can see that option C is the product that we have found. So option C is the correct one. Okay. Moving on to the next question, that is question number 29. Okay. It says that the increasing order of the acidity of the given molecule in aqueous media is. Okay. So the compound. Let me draw the compound. So firstly the compound is phenol, named as compound 1. Then we have acetone, named as compound 2. Then we have one fluoroacetic acid, okay, which is compound 3. And we have methanol, which is compound 4. Now in this case you can see obviously that the fluoroacetic acid will be having the highest acidity. Okay, because it has a carboxylic group, and the F is there to weaken the OH bond. Okay, so 3 would be having the highest acidity. Then phenol, because phenol is obviously acidic, because the conjugate base, that is the phenoxide ion which is formed, that is stabilized by resonance in the resonance in the benzene ring. Okay, so phenol is also kind of like acidic. Okay, in the next case would be like this one. So if this the conjugate base would be CH3O minus. Now this O, like this minus charge is on the O atom, so as O is electronegative, so some kind of acidity would be present. Okay, so this is number 4. And number 2 would be the least acidic, because if minus charge forms over here, the minus charge would be on the C atom, that is an electropositive atom. Though conjugation takes place, that is a different issue, but this is the least acidic. Okay, so 3 greater than 2, greater than 1, greater than 4, greater than 2. Okay, in the options you can see that option C has this order, so option C is the correct one. Okay, moving on to the last question of this video, that is question number 30. We have the compound formed upon subjecting an alpha amine to Lassine test. Okay, yeah, so in Lassine test, what happens is, any compound that contains any N group, that is nitrogen as one of the functional groups. Okay, that nitrogen after reacted forms into NaCN. Okay, functional group. That nitrogen after reaction, after the Lassine test, it in the solution it comes as NaCN. Okay, any nitrogen group. Okay, NaCN. So not NH2, not NaNO2, and not NaN3. Okay, NaCN. And after that we take this NaCN and do test for nitrogen, sulfur, and chlorine, with that is the further procedure of the Lassine test. But NaCN is formed when the N functional group is a compound having N functional group is treated with the first procedure of the Lassine test. Okay, so NaCN obviously is formed. So in the options you can see that option C has NaCN, and therefore option C is the correct option. Okay, so yeah, so let us wrap this video up. In the next video we will be starting the MCQ part of the 2019 question paper is completed now, and the MCQ, MSQ, and the NAT questions are remaining. So in the next video I will be starting the MCQ questions. Okay, so thank you for this video.